Okay, so here is the answer key for the first one. Okay, a 50 Newton bowling ball is at rest on top of a 20 Newton physics textbook, which is on the floor. Okay, so the first thing that we need to notice is that it says it's at rest. Okay, so that's a clue that we're going to say that the forces are balanced. Okay, either at rest or moving at a constant velocity. Okay, but this one's at rest. All right, then we want to make an interaction diagram. Okay, so we have the ball, and I'm going to call this one textbook, right? Because we don't want to use the same letter because then the diagrams are going to get confusing with the labeling, okay? Floor and the earth. Okay, so there's my 4 objects. All right, and now I want to see who is touching. All right, so the ball touches the textbook. All right, and since that's a compression or a surface, that's going to get a normal interaction. Okay, same thing with the textbook and the floor, also a normal interaction because that's like resting on a surface. Okay, and then everybody will get one with the earth. Okay, so we can do ball and earth, we'll get a gravity. Okay, textbook and earth, we'll get a gravity. And floor and earth, again, you can put the gravity, but we're never really going to use that one. So it doesn't really matter. Okay. Let's see. I think that's it for that, right? Okay, so there's my interaction diagram. Okay, everybody that's touching and then everybody with the earth. Okay, notice ball and floor don't get one because ball and floor are not touching. All right. Okay, so now we want to do our force diagram. Okay, so here my feeler is going to be the ball. And here my feeler is going to be the textbook. Okay, so the ball is a little simpler, so I'm going to start with that one. Okay, because the ball, if you notice, only has 2 interactions. All right, so that's a little bit easier, so I'm going to start with the ball. Okay, so I'll do that one in pink. All right, it's almost always easiest to draw the force of gravity first, right? Because that's always going to be there, and it's always going to point downward. Okay, so I'm going to have, make that a touch bigger. Okay, I'm going to have the force of gravity, okay, on the ball from the earth, feeler dealer. Okay, force of gravity on the ball from the earth. Okay, and I notice that this one is a 50 Newton bowling ball. Okay, so when it's an adjective like that, that means it's how heavy the ball is. That means it's the force of gravity acting on the ball. Okay, so I can go ahead and label this 50 Newtons. All right. And then also I'm going to have a normal force. Okay, so since the forces are balanced, I know that those are going to have to be the same size, up and down. Okay, so that's going to be a normal force on the ball from the textbook, right? That's this N interaction that I've drawn. Okay, and I know that that also is going to have to be 50 Newtons because these have to be equal, right? They have to be balanced. Whatever up and down have to be balanced. Okay, 50 up, 50 down. All right. Okay, my next one is going to be the textbook, and if you look at the textbook here, you can see that it has 3 interactions. All right, so I'm going to go ahead and start with the force of gravity, and it's telling me that the textbook is 20 Newtons, which again, when it's the adjective, that's sort of describing how heavy it is, right, what the force of gravity is. So I'm going to draw a smaller arrow, right, because the other one was 50, so this one should be a little smaller. So FG, textbook earth. Okay, and that one's going to be 20 Newtons. Okay, and then I also have the textbook and the bowling ball. All right, so which way is the bowling ball pushing on the textbook? How does the textbook feel it? All right, so the textbook is on the bottom, so it's going to feel like it's being pressed downward. All right, so there's going to be an FG, okay, textbook ball that's going to be pointing downward because the ball is pushing down on the textbook. So the textbook is the feeler, right? So it feels it down. Okay, and then balancing all of that, the only other interaction the textbook has is the floor, so that has to be up. Okay, and it has to be big enough to balance both of those downward ones. All right, you can always adjust the size if you don't like it. Okay, and that's also going to be, whoops, messed up, normal. Oh, that was bad. I hope you catch that. Okay, go back and look at this one because I don't really want to remake the whole video. Shoot. Force of normal textbook ball. Okay, because that's a push. Sorry. Okay, and then upward, force, normal, textbook, floor. Okay, right. Those are both normal forces, right? Because I have 2 N interactions with the textbook, and there's only ever 1 G. Okay, so hopefully we all catch that in time. Okay, all right. Now I don't really know these other arrows, so now what I have to do is I have to look for the Newton's third law pair. Okay, and that's going to happen between the 2 objects that I'm talking about. Okay, so ball and textbook. So I'm looking for the feeler dealer that is ball and textbook. Okay, and I see it here and here. Do you see that's the same thing? FNBT is the same thing as FNTB. Okay, it's just the other direction. All right, so we're going to label this one as a Newton's third law pair. All right. Okay, because that's equal and opposite, and they act on different objects always to be a pair. All right, so I know if on the right, or sorry, on the left, I see 50 newtons, I know this guy has to be 50 newtons because that's the same force. It's just the other side of it. Okay, and downward now, I have a total here of 70 newtons. Okay, 20 from the FG of the ball, 50 from the FN of the textbook. All right, so up, this has to be 70 because it has to be balanced. All right. Okay, not too bad except for the error, but hopefully you fixed it.